Hello, this is Mr. Collier, and today we're doing some arithmetic series problems. Okay, arithmetic series, not arithmetic sequences. A sequence is a numbered pattern, like for example 3, 7, 11, and so forth. These numbers are going up by 4. A series is the addition of terms in a sequence. So if we have 3 plus 7 plus 11 plus 15, this is a series. So a series is the addition of the terms in a sequence. Okay, the actual sum of a series is just the results when the terms are added. So we're going to be adding sequences today. So an arithmetic series has two different formulas that we use in two different cases. So you can find the sum of the terms in an arithmetic sequence by using the following formulas: n out of 2 times 2 times u sub 1 plus n minus 1 times d. That's one formula, one version of the formula. Another version is n out of 2 times u sub 1 plus u sub n. Okay, now how do we know which formula to use? Well, if we look at the formulas, let's look at the second one first. It looks a little bit easier. If you know the number of terms, and you know the first term and the last term, the first term and the last term, then you should use this formula. If you know the first term, the number of terms, and the common difference, then you should use the first formula. So let's take a look at example 2 here. Find the sum of this following series to 18 terms. So up to 18 terms, so that's going to be our n. And we don't know the last term, so we're going to use the first version of the formula. I'm going to do it right here. S sub 18, we're summing 18 terms, equals n out of 2, which is 18 out of 2, times 2 times u sub 1, which is 6, plus, again, we have 18 terms, minus 1. The common difference here is 4, because you're adding, oops, not positive 4, it's negative 4, because you're subtracting 4 each time. So that's going to be a negative 4. Alright, so then you just work this out. That's going to be 18 divided by 2 is 9 times 12 plus 17 times negative 4, which equals 9 times 12 minus 4 times 17 is 40 plus 28, 68, which equals 9 times negative 56, which I'm going to do on the calculator. 9 times 56. 9 times 56 is 504. So your sum here is negative 504. That's S18. Okay, next example, part B here. Use the formula to find the sum of the following series, arithmetic series. So let's take a look. We have, in this case, we have the first and last term. So we can use a second version of the formula, which is S sub n equals, let's take a look at it, n out of 2 times u sub 1 times u sub n. So n out of 2 times u sub 1 plus u sub n, which equals, so in this case we don't have n. So let's just substitute it in here for a second, and then we're going to see if we can find n. So we have the first term, and we have the last term, which is 33. But in order to find the sum, we're going to need to find n. And we did a problem like this earlier. We need to find how many terms are in this sequence. So let's take a look at it. D is equal to, we can do 5.5 minus 3 equals 2.5. So d is 2.5. And we need to use our formula for a arithmetic sequence to find n here. So we're going to use u sub n equals u sub 1, which is 3, plus n minus 1 times the common difference, which is 2.5. Now we can find n by using the fact that the last term is 33. 33 equals 3 plus 2.5 n minus 2.5. And we're going to do 33 equals, now 3 minus 2.5 is 0.5. 2.5n, subtract 0.5. We get 32.5 equals 2.5n. Divide by 2.5. So we're going to do 32.5 divided by 2.5. 32.5 divided by 2.5, which is 13. So n equals 13. And now we know our n. Let's substitute that back into the formula. So we have 13 out of 2 times 36. So let's do that on the calculator as well. 13 divided by 2 equals 10 times 36. And we get 234. So 234 is the sum of the first 13 terms in that series. Okay, next. Okay, next we have this example. Okay, an arithmetic series has 9 terms. The first term is 12. The last term is negative 37.5. Find the sum. So this is pretty straightforward. Has 9 terms. We can use the formula. Let's write down the general formula first. If we know the first and last term, it's n out of 2 times u sub 1 plus u sub 2, u sub n. So s, the sum of the first 9 terms is 9 out of 2 times the first term plus the last term. And we can even just type all that on the calculator right now. 9 divided by 2 times 12 minus 37.5. And we get negative 114.75. Negative 114.75. Okay. Next, we have this problem. Find the sum of the first 75 multiples of 7. The multiples of 7 are 7, 14, 21, 28, and so forth. So the first 75 of those. So we have, now we don't know the last term, so we have to use the first version of our formula. We know that the common difference is 7. So we have d equals 7. The first 75 multiples, so n is going to be equal to 75, and of course u sub 1 is equal to 7 because our first term is 7. So we can use the formula s sub 7, or s sub, let's write down the formula, s sub n equals, oops, let me just back that up a bit. Okay, s sub n equals n out of 2 times 2u1 plus n minus 1 times d. And let's substitute in the values. So s sub 75 equals 75 out of 2 times 2 times 7 plus 75 minus 1 times the common difference, which is 7. And I'm going to finish that down here. S75 equals, and I could even just type all that into the calculator. So 75 divided by 2, oops, divided by 2 times, and let's just bracket, 2 times 7 plus 74 times 7. Close that bracket. That should all work out to 19,950. 19,950. Okay, so that's the answer to part A. That's the sum of the first 75 multiples of 7. Now let me bring down part B here. Okay, that's fine. Find the sum of the integers between 1 and 100 which are not divisible by 5. So that looks a bit tricky. Now we just did the sum of the multiples of 7. We can now do the sum of the multiples of 5. Okay, but we don't want those. We want the sum of the numbers from 100 which are not divisible by 5. So here's what we can do. We can get the sum. We can calculate the sum from 1 to 100. That's pretty easy. We can calculate the sum of multiples of 5 from 1 to 100. Alright? Then if we subtract them, we subtract this, we get our answer. Okay, we get the sum of the integers between 1 and 100 which are not divisible by 5. Alright, so let's try that method. The sum of the integers from 1 to 100 is going to be, well, let's see, S100 equals 100 divided by 2 times the first term plus the last term, which is 1 plus 100. Alright, so let's do that. Now 100 divided by 2 is just 50. So it's going to be 50 divided by 2 times 101, which is 25, 25. So that equals 25, 25. And then we're going to get some of the multiples of 5 up to 100. So that's like 5, 10, 15, all the way up to 100. So in this case, the sum, now how many terms is that going to be? Well, altogether that's going to be 1/5 of all the numbers from 1 to 100, so it's going to be 20 terms. So n equals 20. So the sum of these 20 numbers is equal to 20 divided by 2 times 5 plus 100. So let's go ahead and do that. So that's just actually 10 times 100 and 105. It's equal to 1050. Okay. Now let's just back up a second. I just made an error in the first one. This should have been 50 times 101. I think I divided by 2 twice. Let me go back and do that. That should be 50 times 101. And then we get 50/50. So that should have been 5,050. And now we're going to subtract. Okay, we're going to subtract 5,050. Take away 1,050 is actually 4,000. So therefore our answer is 4,000.